Question 13, we are discussing how to solve problems from the topic inclined plane. So we have an inclined plane here, an inclined plane. So this is the inclined surface and this is the our horizontal, means our ground. So that is this is the horizontal, this is the horizontal, and this is the inclined surface. And what is this? What is this? This is the angle of inclination, the angle made by the inclined surface with the horizontal. For example, that angle of inclination we will take 30 degree. So theta equal to 30 degree. The angle theta, that is equal to 30 degree, and this angle is called angle of inclination. Then here is an object, or you, this is a slide in the park and you are sliding on this slide. So what is the mass? For example, we will take mass of this object is 5 kilogram. Mass of this object, so I will write here, mass of the object is equal to 5 kilogram. That is the mass. So what are the forces acting on this object? Primarily, means at first the weight will be acting vertically downward, right? Weight always act in the downward direction. So the weight of the object will be acting vertically downwards. So this is weight we will write mg. Weight is equal to mg. And there will be another force. That force is the normal force. Normal force will be always normal to the surface. Normal means perpendicular. So always perpendicular to the surface. So this is the normal force. Normal force always make an angle 90 degree with the inclined surface. And there is a chance that this object will slide downwards, right? So if it is moving downwards, or if it means it will have a tendency to move down, right? Slide down. So there will be a force of friction, that we will write force of friction in the opposite direction. The next, weight is acting vertically downwards. This weight we will divide into two components. The x component means the parallel component and the perpendicular component. Parallel to what? Parallel to the inclined surface. So we will divide this weight into two components. One is the parallel component. This is mg sine theta, and the perpendicular component, this is mg cos theta. Then we have already discussed in the inclined plane, the normal force will be always equal to mg cos theta, right? Normal force will be always equal to mg cos theta. Why? Because normal force is opposite to mg cos theta, as the object will not accelerate up or accelerate, means into the plane. Normal force will be equal to mg cos theta. So how to solve the question? For example, question number 1. First question, calculate the parallel and perpendicular components of weight of the object. If a child is sliding, that will be weight of the child, weight of the object here, weight of this box. So how to calculate the parallel component? Parallel component of weight, that is equal to what? Parallel component is mg sine theta. Mg sine theta equal to, what is m? Mass of the object. How much? 5 kilogram. 5 multiplied 9.8 multiplied sine theta. What is theta? Angle here. How much? 30. So sine 30 equals 5 multiplied 9.8 multiplied sine 30. 5 multiplied 9.8 multiplied sine 30 equals 24.5. 24.5. What's the unit? Foresight. So Newton. How to calculate the perpendicular component? Perpendicular component is equal, means mg cos theta, right? This is mg. This force we can divide into two components, mg sin theta, mg cos theta. Mg sin theta is the parallel component and perpendicular component is mg cos theta. So perpendicular, that is equal to mg cosine theta, which equals, m is how much? 5 multiplied 9.8 multiplied cos angle. Cos angle is 30 degree, right? Yes. So 5 multiplied 9.8 multiplied cos 30 equals 42.4. 42.4 Newton. So this is the parallel and perpendicular component of the weight. Question number 2. Question number 2. Calculate normal force. Calculate normal force. How to calculate normal force? Normal force is always equal to mg cos theta. So normal force is equal to mg cos theta, which equals, what is m? Mass of the object 5 kilogram. Whatever the mass is given, whatever the mass of the object, you can use that. So mass is equal to 5 kilogram, g 9.8 multiplied cos 30, which equals, we have just calculated, right? 42.4 Newton. So normal force is always equal to the perpendicular component of the weight of the object or weight of the child. If you are you are solving a question in that a child is sliding on an inclined surface, inclined plane. Okay, the next question number 3. Question number 3. The box is sliding down the inclined plane at a constant speed. The box is sliding down the inclined plane, at a constant speed. At a constant speed means at a steady speed. So calculate what? Calculate the coefficient of friction. Coefficient of friction. Calculate the coefficient of friction means you need to calculate mu. While discussing the questions from friction, we have discussed you can calculate friction only if you know you can calculate coefficient of friction only if you know the value of friction, value of the frictional force. Okay, so to calculate friction, to calculate coefficient of friction, to calculate Coefficient of friction, first you have to know what is the value of the friction, but that is not given in the question. What is given in the question? In the question it is given that the box is sliding down or moving down at a steady speed, at a constant speed. So if it is moving at a constant speed, we know that if any object is at rest, or moving at a constant speed, then what? Opposite forces are equal. If an object is at rest or moving at a constant speed, opposite forces acting on the object are equal. Opposite forces are equal. So here this box is sliding down the inclined surface at a constant speed, so opposite forces are equal. So what force is opposite to friction? Mg sin theta. Mg sin theta is opposite to friction. Mg sin theta. What is m? Mass of the object 5 multiplied 9.8 multiplied sin 30. How much? We calculated, but I forgot this. 24.5, right? 5 times 9.8 times sin 30. How much? Correct. 24.5. So normal force is equal to 24.5 Newton. That is question number 3. If in any question, if they ask you to calculate frictional force when the object is moving at a steady speed, the equation is frictional force is equal to mg sin theta. So you calculated friction, but here you have to calculate what? Coefficient of friction. So how to calculate friction? If you know friction, you know that coefficient of friction always equal to frictional force divided by normal force. Frictional force divided by normal force. Frictional force you already calculated and you got 24.5 divided by normal force. What's the value of the normal force? Normal force is equal to mg cos theta, right? So mg cos theta, 24.5 divided by m is 5 multiplied g 9.8 multiplied cos 30. Cos 30 how much? We will calculate this value. 24.5 5 times 9.8 times cos 30, which equals 42.4, right? 42.4. So 24 divided by 42.4, 24 divided by 42.4. That step you have to write. Okay, there is no space here. That is why I deleted that. So 24.5 divided by 42.5, which equals 0.58. 0.58. What is the unit? Coefficient of friction has no unit, and always when you calculate coefficient of friction, you will get a value that is equal to less than 1. So we got here less than 1. Okay. Question number 4. I am giving you like different types of question that you can expect from this topic, inclined surface. Question number 4. Number 4. What is the question? The box or the object is sliding down at a or sliding down with an acceleration. The coefficient of friction, between the surfaces is 0.57 is the coefficient of friction between the surfaces. Coefficient of friction between the surfaces I will make 0.3. So calculate acceleration of the object. Calculate acceleration of the object. Sliding down with an acceleration, right? Sliding down with an acceleration. So which force will be greater? Will frictional force will be greater or mg sine theta? Mg sine theta will be greater than the frictional force. That is why it is sliding down. So we can write the net force is equal to mg sine theta minus force of friction. Mg sine theta minus force of friction. So first we will calculate the force of friction. Force of friction we will calculate and we will substitute here. Force of friction, that is equal to coefficient of friction into normal force. So force of friction, that is equal to coefficient of friction I have given in the question 0.3. So 0.3 multiplied, what is the normal force? Normal force is mg cos theta. M is 5, g 9.8, cos 30, which equals 0.3 multiplied 5 multiplied 9.8 multiplied cos 30 bracket close, which equals 12.7 Newton. That is the force of friction. So what is mg sine theta? Mg sine theta also we will calculate and we will substitute. M is how much? M is 5 multiplied g 9.8 multiplied sine 30. 24.5, right? Yeah, that we did many times. So 24.5 minus force of friction 12.7, that is equal to mass multiplied acceleration. So how much? 24.5 minus 12.7, which equals 11.8. So mass multiplied acceleration is 11.8. So what is the acceleration? Acceleration is equal to net force. So this is the, means just to divide this, right? 11.8, because mass multiplied acceleration is 11.8. So what is acceleration? 11.8 divided by mass. 11.8 mass is 5 kilogram, right? So 11.8 divided by 5 which equals 2.36 meter per second squared will be the value of the acceleration. So these are different types of questions you can expect from inclined surface. I hope you understand this. So we will move on to the next question. Now I am not explaining like one question one by one. I am explaining how to solve questions from that particular topic. Question number 14. Determine the magnitude and direction of resultant of two vectors in two dimensions using trigonometry, Pythagorean theorem, law of sines and law of cosines. So now we are moving to question number 14. Are you ready, students? Do you have your notebook and pen to write the notes? Yes. Question number 14. So we will discuss how to solve the questions. Okay, I will give you different types of questions. I am not explaining the exact questions given in the textbook, but I am explaining how to solve, okay, by giving one example. First, number one. You are walking 6 kilometer to this direction, or you are driving 6 kilometer, not walking, okay, driving 6 kilometer to the east. Then after that you are driving in this direction, for example 4 kilometers. So where did you start? You started from here. This is your starting point, correct? That is your starting point. And where did you reach? You reached here. This is where you reached, the destination. So starting to the end, what is the resultant? Resultant is always from starting to the end. How to calculate the resultant? Very easy. Why? Because here the angle between two displacement or angle between two vectors is 90 degree. So if the angle between two displacement or angle between two forces or angle between two velocities means angle between two vectors is 90 degree, then to calculate the resultant you can use Pythagorean theorem. What is Pythagorean theorem? The resultant is equal to square root of this square plus this square, 6 square plus 4 square. What is 6 square plus 4 square? Square root of 6 square plus 4 square, which equals 7.2. So the answer is 7.2. 7.2 kilometer is the resultant displacement. 7.2 kilometer. 7.2 kilometer in which direction? So to find the direction, you have an equation. Direction is the angle, okay? Direction is the angle. So the direction or angle theta, that is equal to tan inverse opposite side divided by adjacent side. So tan inverse, so we will find this angle, okay? For example, this angle is theta. So what is the direction of the resultant? What is the opposite side for this angle? If you are here, you are standing like this, what's your opposite side? That side. So this is you. What's your opposite side? This one, 4 kilometer. So 4 kilometer divided by, what is your nearby side? Adjacent side. With that side you are making the angle, see? That is 6 kilometer is the adjacent side. So this is the nearby side, right? Adjacent side means the nearby side, that is 6. So tan inverse 4 by 6, how much? Shift tan inverse 4 divided by 6, which equals 33.7. 33.7 degree. So how to say the angle? We can say the resultant is 33.7 degree south. The resultant is the resultant displacement is how much? 7.2 kilometer, right? 7.2 kilometer. In which direction? 7.2 kilometer. 33.7 degree south. 33.7 degree south of east, right? South of east. 33.7 degree from east towards south. So how do we write that? 33.7 degree south of east. Okay. The next question. So we have done one type of question. What is that type? That type is if the angle between two displacement or two forces is 90 degree, then to find the resultant you will use square root of first one square. I will write a square plus b square, means one square plus the other square. Okay, one square plus the other square. There is no first and second. Okay, there is one and the other. Okay. Then next you are walking 4 kilometer. Then you are turning 45 degree to your right side. You are walking like this, turning 45 degree to the right side and walking. So walking like this. For example, 4 kilometers. This angle is 45 degree. What is the resultant? Resultant displacement is from the starting to the end. You started from here and you reached there. So this is your resultant displacement R. How to calculate? You cannot calculate using this equation. R is equal to a square plus b square. That you cannot use. Why? Because you can use this equation if the angle between them is 90 degree. So here angle between these two displacement is not 90 degree. It is more than 90, right? You know that this is more than 90. How much? See, if it is up to here, this is 90. If this is 45, this will be 45. So this total will be 90 plus 45. 90 plus 45, how much? 135. 90 plus 45 is 135 degree. So angle, you know now, you know the angle, right? So yes, you know what? You know two sides, right? You know two sides. And you know one angle. If you know two sides and one angle, then you can use cosine rule. You will use cosine law. Cosine law. What is cosine law? Cosine law states that the displacement is equal to square root, means the resultant is equal to square root of a square plus b square minus 2ab cos theta. Square root of a, any of this is a, any of this is b, so I will write 6 square plus 4 square minus 2 multiplied 6 multiplied 4 multiplied cos 135, which equals square root of 6 square plus 4 square minus 2 multiplied 6 multiplied 4 multiplied cos 135, which equals 9.27 kilometer. So this is the second method or second type of question where you can use the cosine law. Where will you use cosine law? Number one, when the angle is not equal to 90 degree, when angle between two displacements, or when angle between two forces, or when angle between any vectors, two vectors is not 90 degree, and you know the value of two sides and one angle, so that you will use cosine law. Then I will give another type of question. For example, this angle is 135, right? 135, and this side is not given. Instead of that, this angle is given. This angle is, for example, I will give you another question, okay? We will change the question. You are walking again 7 kilometer now. Now you are walking more distance, but this direction, for example, you are walking here 4 kilometers. Okay, so this angle is given. This angle is given as 120 degree. 120 degree is that angle, and this side is not given. Okay, anyway, that side is not given. That side you don't know. By mistake I wrote, you don't know that side. So instead of that, you know this angle. This angle is 30 degree. And this one, that also don't know, means you don't know the resultant. And you are question, it means question is for you to calculate the resultant, Okay, you are walking 7 kilometer. then you turn at an angle, then walk to this side. You don't know how much you walked this side, no information given about the distance in the question. But what is given? This angle is given, we know this angle, and the question is to calculate the resultant. So first, what do you know? You know one side, length of one side you know, and you know two angles, right? Values of two angles you know. If you know one side and two angles, you will use sine law. Sine law. Before, you know two sides and one angle. If you know two sides, if two sides and one angle is given in the question, you used cosine law. In the question, you know value of one side and two angles, you will use sine law. How to use the sine law? Sine law states that one side divided by sine of the opposite angle. Sine of the opposite angle. So what angle is opposite to this side? To this side, the opposite angle is 120. So r divided by sine 120, which equal to the side divided by, for example, we know this side, right? 7 kilometer. 7 divided by sine of the opposite angle. So what angle is opposite to this side? For this side, this angle is opposite 30. Sine 30. So what is r? R is equal to 7 divided by sine 30 multiplied, this will go to the other side, multiplied sine 20, sine 120, 120, 120, which equals what? We will calculate and write the final answer. 7 divided by sine 30 equals 14 multiplied sine 120, which equals 12.1. 12.1 kilometer is the value of the resultant. So these are means different methods to calculate or to solve different types of questions. If the angle between two vectors or two forces are 90 degree, then you can use Pythagorean theorem. Resultant is equal to square root of a square plus b square. If the angle is not equal to 90 degree and you know values of two sides and one angle, you will use law of cosine. What is law of cosine? Resultant is equal to square root of a square plus b square minus 2ab cos theta. See, the angle is not equal to 90 degree. You know two angles and one side. You will use law of sine or sine law. What is sine law? Side divided by sine of the opposite angle equal to other side divided by sine of the opposite angle to that side. Question number 15. Explain the motion of horizontally launched projectiles and show schematically the components of velocity and acceleration. That we have done with question number 1. We have explained that in question number 1. Question number 16. Demonstrate by experiments that acceleration of an object is directly proportional to the force applied and inversely proportional to the mass of the object. Newton's second law, that also we have explained in the previous questions. Question number 17. Apply Newton's second law to solve numerical problems. So apply Newton's second law to solve numerical problems. So what is Newton's second law? Question number 17, right? Question number 17. Newton's second law states that acceleration of an object that is equal to the net force acting on the object divided by mass of the object. Net force acting on the object divided by mass of the object. For example, an object its weight is equal to, the weight of the object is 520 Newton. 520 Newton is the weight of the object, and for example, this is that object. You are applying a force here. You are applying a force of 50 Newton, and there is a frictional force acting in the opposite direction, right? Frictional force always act in the opposite direction, 20 Newton. And the question is to calculate the acceleration. So to calculate acceleration, what is the equation for acceleration? Acceleration is equal to net force divided by mass of the object. Here net force is not given, mass of the object is also not given in this question. So first we will calculate the mass of the object. Weight is given. So mass is equal to weight divided by G. The value of the weight is 520 divided by value of G is 9.8. So 520 divided by 9.8. 520 divided by 9.8 equals how much? 53.1. So 53.1 kilogram is the mass of the object. How did we calculate that? We know that weight is equal to mg. So m is equal to weight over g. Then we have to calculate the net force, right? So if we know the net force, we can calculate the acceleration. F net is equal to forward force minus backward force, means the applied force minus frictional force. Applied force is 50 Newton that you are applying, and 20 Newton is the frictional force, so 30 Newton. 50 minus 20 is 30 Newton. That is equal to net force, right? Net force. So net force is 30 and mass is 53.1. So what's the value of the acceleration of the object? 30 divided by 53.1, which equals 0.56. 0.56 meter per second squared is the acceleration of the object. So this type of questions you can practice more, and this is the second law, means use Newton's second law to solve numerical problems. And the inclined plane questions we have explained already. Question number 18 lists the characteristics of interaction pair, and the means action reaction pairs for different situations, that also we have explained. And we have explained the similarities and differences between action and reaction, means similarities and differences of interaction pairs. Question number 19, apply Newton's laws to solve problems involving numerical normal force, tension, including the system of objects. So tension, the type of questions we have done already. Question number 20, to solve questions about projectile motion. So to know in detail about the projectile motion, I have done a video about horizontal projectile motion. You can watch that. And here I will discuss one question from the horizontal projectile motion and explain the motion of projectile launched at an angle. So horizontal projectile motion, one question we will solve here. Question 20. You throw a stone horizontally at a speed of 5 meters per second. For example, where are you? From the top of a cliff, right? So this is a cliff and you are here on the top of the cliff. You are throwing a ball from here in a horizontal direction at a speed of 5 meter per second, so 5.0 meter per second. And this cliff is at a height. What is the height of the cliff? The height of the cliff is 78.4 meter. 78.4 meter is the height of the cliff. So the ball will be following a path like this. It will follow a curved path. So it will reach the ground here. Then what do you have to calculate? You have to calculate how long does it take the stone to reach the bottom of the cliff. So question A, you need to calculate how long. What is the meaning of how long? How long is equal to time, right? You have to calculate the time taken to reach the ground, time taken by the ball to reach the ground, and how far from the base of the cliff does the stone hit. How far means this distance, delta x. So if the question is how far, which is equal to delta x, the horizontal distance traveled, or it also called horizontal range, okay, distance traveled, or the horizontal distance traveled, or how far. Then question number C, what are the horizontal and vertical components of the stone's velocity just before it hits the ground? So when the ball hits the ground, it will have a horizontal velocity and a vertical velocity. So we have to calculate what is the value of this horizontal velocity and what is the value of the vertical velocity. So we have to calculate the final velocities, final horizontal velocity and vertical velocity. So these are the three questions in this A, B and C. So we have already discussed some things about the projectile motion in question number 1. Number 1 is a projectile has both horizontal motion and vertical motion at same time. So here I will write a horizontal motion, here I will write vertical motion. So in horizontal motion we have only one equation, that is delta x, means the distance traveled in the horizontal direction, that is equal to horizontal velocity multiplied time. And in vertical motion we have three equations. First one is final velocity, means final vertical velocity, that is equal to initial vertical velocity plus acceleration into time. The next delta y, that is equal to initial vertical velocity into time plus half multiplied acceleration multiplied time squared. And we have a third equation, that is final velocity square is equal to initial velocity square, initial vertical velocity, okay, in vertical motion all vertical component, 2 multiplied acceleration multiplied delta y. And here we have like in every projectile motion, or you have studied in the term 1 the equations of motion. So when you were studying the equations of motion, you know that there are 5 things, right? So what are the 5 things? In every accelerated motion, okay, initial velocity, final velocity, acceleration, displacement and time. So initial velocity, final velocity, acceleration, displacement and time. So in every accelerated motion we have these 5 data. So here when we will use the first equation, you can see in the first equation what is not there. Final velocity is there, initial velocity is there, acceleration is there, time is there. What's not there? The displacement is not there, delta y is not there. So you can use the first equation, you will use the first equation if no delta y in the question, no delta y, no displacement, no vertical displacement is given in the question. What is missing in the second equation? Vf is missing in the second equation. So you will use the second equation if no final velocity in the question, and you will use the third equation when there is no time given in the question. Okay, so these are the basic things to know before you solve the problems in projectile motion. Okay, so here what are the things? In the horizontal motion we have only delta x, means horizontal distance, and vx horizontal velocity and time. Okay, So what is given here? Delta x is not given, right? Okay, we will just change the path because we need some space here. And the height of the cliff we will write here. Height of the cliff is how much? 78.4, right? 78.4 meter. And this is the path followed by the projectile. So horizontal velocity and vertical velocity. Okay. So what we know? We know here. What do we know here? Here we know the Vx, right? Velocity, that is 5.0 meter per second. And we need to calculate the time. So to calculate the time, what is the equation? We can calculate how long means time taken, right? So to calculate time, we can write the equation time is equal to delta x divided by Vx. Time is equal to delta x divided by Vx. Means just rewriting that equation. But we cannot use this equation. The problem is to calculate the time we have to know delta x, but delta x is not given in this question. So we cannot use this equation, or we cannot use horizontal motion to calculate time. So if we cannot use horizontal motion to calculate time, we will go to the vertical motion. First we will check, can we calculate the time from the horizontal motion, because there is a simple equation. If horizontal velocity and a horizontal distance is given, we can directly use this equation to calculate time. But here horizontal displacement, horizontal distance traveled is not given, so we cannot use this equation. We cannot use horizontal motion, so we will go to the vertical motion. So what is given here? So you are throwing the ball in a horizontal direction. So what initial velocity along the vertical direction is 0, and final velocity along the vertical direction we don't know. Not given the final velocity. No final velocity in the question, or no information about final velocity. What's the acceleration? Acceleration will be always 9.8 meter per second squared. So it is in the downward direction. I am considering downward direction as positive. So that's why I am not writing the negative sign here. So acceleration is equal to 9.8 meter per second squared. Acceleration will be always 9.8 in the case of projectile motion, whether it is horizontal or angular. And delta y, height of the cliff, the vertical height, 78.4 meter. So I will write here 78.4 meter. Time we need to calculate. So we have to calculate time and no final velocity. If there is no final velocity, which equation will you use? Which equation will we use? See, if there is no final velocity, then in the equation final velocity should not be there and time should be there, because you need to calculate a time. So which is that equation? This equation, right? No final velocity and a time is there. So what is that equation? We will select the second equation, delta y, that is equal to initial velocity into time plus half multiplied acceleration multiplied time squared. So what is delta y? Delta y is 78.4 meter. Initial velocity is 0, so this term will be 0. So half multiplied 9.8 multiplied time squared. We need to calculate time, right? So I will rewrite this equation for time squared, or what you can do is you can use shift solve. 78.4 equal to half multiplied. I will use shift solve. Okay, why to make it complicated? Let us try shift solve. 78.4 equals alpha equals 0.5 multiplied 9.8 multiplied alpha x squared shift calc equal, why I got syntax error. Okay, so I will use the other method. Yes, so t square is equal to 2 multiplied 78.4 divided by 9.8. So if you want to calculate t, then it will be square root. So square root 2 multiplied 78.4 divided by 9.8, which equals 4. So time I got 4 seconds I will try shift solve again. 78.4 alpha equal 0.5 multiplied 9.8 multiplied t squared, right? So bracket alpha x squared bracket close shift calc equal. I am getting again syntax error. I don't know what is the mistake I am making there. So we got the time, right? We got the time. So time is equal to 4 seconds, that we will write here. Time is equal to 4 seconds. Then what is question B? In question B, we have to calculate how far the base of the cliff does the stone hit the ground. So we need to calculate what? How far? How far means what? How far means delta x. What is delta x? Delta x you can calculate Vx into t. T already you got, right? Vx how much? 5. T already you calculated 4. So 5 into 4 is equal to 20 meter. Done. Then question number C. Question C, the part C of the question. What are the horizontal and vertical components of the stone's velocity just before it hits the ground? So what is the horizontal velocity? Vx. Horizontal velocity when the ball reach here, the ground. So this is Vx, horizontal velocity, that will be constant throughout the motion, that will be equal to the initial velocity. What is the initial value of the horizontal velocity? 5 meter per second. So it will be the final velocity, final horizontal velocity also 5 meter per second, because horizontal velocity of a projectile never change. It will be constant throughout the motion. If the initial velocity is 5 meter per second, then final velocity will be also 5 meter per second. Okay, final velocity in the horizontal direction. So what is final velocity in the vertical direction? That you have to calculate. How to calculate final velocity? Final velocity in the vertical direction you can calculate using this equation. Final velocity is equal to initial velocity plus acceleration into time. So what is the value of the initial velocity? Initial vertical velocity is 0, acceleration 9.8, time is equal to 4. What is 9.8 into 4? 9.8 multiplied 4, which equals 39.2. 39.2 meter per second. So this is how you have to solve numerical problems from projectile motion, and there are some more questions mentioned in the Heikel from the textbook. So I will conclude this video here. Thank you all the students for watching the video. If you like this video, you can share it to your friends and classmates, and good luck for your examination. I hope all of you will get perfect A+ for this term 2 physics examination. Thank you again.